Now say induced EMF due to rotation of conductor. See, let PQ is a conductor of length L and it is moving about an axis perpendicular to the plane of loop, perpendicular to the plane of board with angular velocity omega in uniform magnetic field B. So now we want to find how much induced EMF developed. First of all, we will go with the very basic relation. Our relation for EMF is given as V cross B dot dr. This is a very basic relation here. Now, when we will see the rotation of this our conductor, so what have been observed, if we are moving from P point to Q point, different point of the conductor will have different velocity. Although angular velocity is same, but as the different points are at different distance, so their tangential velocity will be different. V is the velocity, you can say translational velocity. So translational velocity of different point is different. So different point produces your different EMF. So we can say it is equivalent to just like a number of EMF source between P and Q point. So first we will say how to calculate that EMF. Let we are taking a small element at distance r dr. So velocity of this V, which is written as r into omega. Now, according to the polarity V cross B, V is your upward direction, B is your inward direction, V cross B your left side. So P will be at higher potential than Q. And now between these 2 points, how much EMF induced, that we can get from here. So dE. V cross B, VB sin theta, velocity V is your r omega, and B is magnetic field, and angle between the velocity and magnetic field is 90, the sin 90, and dr. dr in this direction and V cross B in this direction. So angle between dr and V cross B are 180. So dr cos 180. Now, so this can be written as omega B r dr. Then we will integrate with minus sign. R is 0. It means point P. R is your L, point Q. So this is your EP minus EQ half B omega L square. This is the EMF now. So we can say this is the potential difference between P and Q point. So it is equivalent to number of different battery likewise from Q and P, and each we can say have EMF E1, E2, E3 like this. So EPQ, EP minus EQ is nothing. It is the summation of all these EMF. This is the meaning of EMF, or in that manner we can calculate the induced EMF due to rotation of conductor. Now, see, let's take another example. When the rotation is not about one of the end, let rotation is about one end which is let inside. See, let another case in which our conductor your PQ same, magnetic field is also same, but the rotation is about O with angular velocity omega, and this O is at a distance L by 4 from one of the end and 3L by 4 from the other end. Then how to calculate? It is similar to the previous case. Similar to the previous case, see, it is just like there is a two conductor P and O and O and Q. One of that have length L by 4, another your 3L by 4. Method is absolutely same. So when it is rotating means this is the omega. So see, if I am looking the OP part, velocity or downward right now and magnetic field your inward, so force acting your V cross B direction your towards O, so it is similar to one of the source of EMF between P and O, let this your E1. Similarly, when we are looking for O to Q, it is your magnetic field your inward, but velocity or upward, see the direction of force your right side, so it is similar to the one another EMF source E2. So likewise, it means this, it is equivalent to just like a two source of EMF having value E1 and E2, and as we know, due to rotation of conductor, our magnetic field your B omega L square. L is the length of respective conductor. Here OP length your L by 4. So E1 is your 1 by 2 B omega L by 4 square, and so this become your B omega L square by 32, and E2, if I am talking about E2, half B omega 3L by 4 square, so this is your 9 B omega L square by 32. Now if I am looking the between P and Q, so see, simply we can apply Kirchhoff law. EP plus E1 minus E2 is equal to your EQ. The EP minus EQ is your E2 minus E1, and E2 minus E1 means this minus this here, so B omega L square by 4. So this is the induced EMF between P and Q. In this manner we can say. Let's see another example. Now if we are having a semicircular conductor, we are having semicircular conductor, like this, and this conductor have radius R, O is the center, PQ is the total conductor length, and now it is given the point C, somewhere here point C, the arc PC is making an angle theta. Now our conductor is your rotating about this point C in uniform magnetic field B. Then how to calculate? See, in uniform magnetic field B, then how to calculate? As we know, in case of irregular shape conductor, we can join the ends point. So it is just like one conductor we are having PC length, another your CQ. See, it is equivalent to one conductor like this PC and another is your like this CQ. And now main point is the determination of these length. See, like this. So first of all, how to get this value? This angle given here theta. See, in this triangle, OC and OR is your isosceles triangle, as well as this makes an angle here 90. So if this arc is making here angle theta, so this angle will be your theta by 2, the first thing. As this angle here 90, the CQ value will be your 2R cos theta by 2. And now CP is your 2R sin theta by 2, and it is rotating with angular velocity omega. In uniform magnetic field B, like this. So we can say magnetic field here uniform. We are having two conductor, one CP, another CQ, and these are rotating like this. See, same relation we can use. As the velocity are in this direction, magnetic field are inward. See the direction of V cross B. V cross B or towards C for PC, and when we are looking the QC, then also it is towards C. So overall this can be said that the whole act as a two batteries, one between P and C is at higher potential, let EMF E1. Another is your between C and Q, this also here C is at higher potential. So now we can apply Kirchhoff law from P to Q, and value we can calculate E1. E1 is your half B omega L square. L is the length your CP. CP is already we have found 2R sin theta by 2 whole square, and E2 your half B omega 2R cos theta by 2 whole square. Then apply Kirchhoff law here. So EP plus E1 minus E2 is equal to EQ. So EP minus EQ is E2 minus E1, and we can calculate the value after putting these values. So in this manner we can calculate the induced EMF due to rotation of conductor.